afternoon, everyone. Hope you are fine. And I am Dr. Shiraz, an instructor of electronics course on behalf of UTEL University, Manila. Uh, I am here to teach you this subject for the current course, that is electronics. And I have uploaded the different modules related to this course on your walls and on your emails as well. This recording is particularly being done for the students so that if they have missed the lectures, they can go through these recordings and find themselves comfortable for their learning activities and for giving their exams. I have sent certain emails as well to the students asking them to please join the classes and try to spare some time out of your busy schedules and do available for the lectures. This is very, very, very important because being present over here, you should be able to participate with the course contents as well as you can ask certain questions and we can ask certain questions from you. So there should be some understanding between the teacher and the class that they are picking and learning whatever we are teaching them. Anyhow, as coming to the first thing of the course, I'm sharing you the screen. Now, as we are on the start of our lectures, so in week one, first of all, we welcome to you in our first collaborative activity, whose objective is to expand your learning through interaction with your colleagues, ratifying or rectifying your first conclusions. Computers are tools that have helped human beings across the history. Now, why we are teaching this electronic subject? Because all the devices which we use today, that is mobile or the computers or anything in the this digital world, they are made with the help of the computer, with the help of the electronics. So we should be able to understand the basic concepts of the electronics, that how these things work. Electronics are the way to build and give services to those devices so as to understand how electronics has changed the world around us. And we will be explaining some basic concepts in it. Now, every forum of this course will last for 2 weeks and its development will have two stages. Be on the lookout for the second introduction because the task is considered complete if you cover what is requested in both. After reading the text presented in the resources section of week one, the students will be able to answer the following questions. Why is it important to use electronics in a computer? 2. Which considerations should we take when we fix an electrical problem? 3. Which safety concerns should we consider when dealing with the electricity? And read the article and discuss with at least another student that what are the concepts which we are studying and what are the things which we have to keep in mind. You can see there is a link which I will be sharing you on the forum as well. Please check this link to check out the configuration for this electronics course and the safety concerns. Now, I will be sharing you with a PDF file, and this PDF file will be very helpful to understand what we are going to learn. So this PDF file I will also share with you people in the forum as well, and it is available in the resources material as well. The book is named as Electric Circuit Principles. So coming to the introduction. But before going on to the introduction, I want to understand how much you people know about this electronics. Have you ever been through this electronics course, or somewhere you have some type of learning or understanding for this course? So let's have a first question of the open forum. Question number one. Now the first question is, what is electronics and how much understanding you people have about electronics? So you people should search this thing in your free time and explore yourselves that have you ever been through this word? Have you ever been through this topic? And in the daily life, what devices you come across in which this electronics is involved, right? So when I will be finishing my lecture, hopefully you will also be able to give the answer to this question. So now again, we come back and share that PDF file and try to learn the basic concepts which are involved in electric circuit principles. Introduction. This document discusses some basic concepts in electronics like atomic structure, electric charge, voltage, current, and resistance. Voltage and current sources, resistors, their types, and finally, how we can design the electric circuits. Understanding these concepts is essential to understanding the science behind electronic technologies and thus interpreting different causes of the phenomena associated with electronic technologies and executing a good electronic design. When you finish this reading summary, we hope that you will be able to express the concept of voltage, detail the concept of current, and apply them to a basic electronic circuit. Now, the first thing is, what do you mean by atomic structure? Let's see. Now, we know that everything we come across in this world is matter, right? Everyone of knows this thing. And this matter is found in nature in three types: solid, liquid, and gas. But all this matter, whether in any form, can be broken down into small structures called atoms. There was a scientist, very famous. His name was Niels Bohr. He proposed the accepted model of the atom in 1913. According to the researcher, it is very similar to the solar system. As in our solar system, we have the sun as the center, and there are several, like Earth, planets which are rotating across the sun. Now, the sun can be considered as a nucleus, and the planets are rotating in orbits around this nucleus in orbital paths. Similarly, atom has a nucleus, and there are several orbits which are rotating around this center, and these are known as electrons. The nucleus is an accumulation of particles called protons and neutrons. The protons are positively charged, neutrons are negatively charged, and electrons are negatively charged. The atom is considered the fundamental structure of matter because it retains the same properties as the element it comes from. Each of the 109 elements of the periodic table are differentiated by the number of electrons and protons that its atom contains. Now, as I've said that all the world is made up of matter, and the matter is divided into solid, into liquid, and gas. Now, there are many elements available in nature, and many compounds are made with the help of these elements. There are till date 109 elements which are present in the world, and we have categorized them in a table in chemistry which is known as periodic table. These categories are made on the basis of number of electrons present in the outermost shell and the total number of electrons which are present around the nucleus. The electrons which are present, they are in maximum of 8 number in one orbit, and the things goes on like this. One orbit, now let's suppose for example, we have an element with 38 electrons in its around surrounding its nucleus. Now the first element, the first orbit of the element will contain 2 electrons. Then we have 8. The first one must have only 2 electrons. Please keep this thing in mind. After the 2, there will be 8, and so on, maximum of 8. So 2, 8, that makes 10. 10 plus 8, 18. 18 plus 8, 26. 26 plus 8, 34. So the remaining 4 are in the outermost shell. So that is how the categorization is done. That the outermost shell will have 1 electron, 2, 3, 4, 5, 6, 7. How many electrons? It can also have maximum of 8 electrons. Now, for example, the hydrogen atom has 1 electron in a single orbit and 1 proton in its nucleus. All the periodic table elements have equal number of electrons and protons, which may make them radically neutral. That is, they have neither positive charge nor negative charge. because if your positive and negative charges are equal, it means that the atom will be electrically neutral in nature. In normal conditions, there are as many positive electrons, positive protons, and as much of negative electrons so that the total charge effect is cancelled and we have zero charge on the atom. As I have told you earlier as well, the elements in the periodic table are arranged according to their atomic number, which refers to the number of protons in each nucleus of the atom because the two are always the same. The number of protons must equal to the number of electrons. Keep this thing in mind. Now, a question arises over here. If the charges is the same, what is the value of this charge? So, at this point again, we have a question for you. Now, the second question for you people in this lecture is, and you should search out for this thing, what is the total charge present on each electron or each proton? Is the value the same on electron or proton, or the value is different for the both electron and proton? So this is the second question for you people. Coming back to the lecture, now we were here. As I have said, the elements in the periodic table are arranged according to their atomic number, which refers to the number of protons in each nucleus of atoms. Not all the electrons in an atom are in orbit. Electrons travel in different orbits around its nucleus. The electrons closest to the atom have lower energy than those farthest from the nucleus. The orbits are also known as energy levels and delimit layers between the different levels. When an electron increases in energy, it rises in layer or energy level, similarly to when an electron loses energy or energy level. Now, this concept is very important to understand. As I said earlier, that the electrons are revolving around the orbit and they are present in different orbits. These orbits are of different energy levels. Those electrons which are present closest to the nucleus have lower energy than those farther from the nucleus. So if, for example, the electron is present in second energy level or second energy shell, it is also known as shell, SHELL. It is also known as orbit, it is also known as energy level. So if an electron is present in second energy orbit or shell, its energy level is less than the one which is present in the fourth or fifth energy level. Now, similarly, if an electron gains some energy from the environment or by collision with another electron, it jumps from a lower level to a higher level, that it may jump from energy level 2 to 3. Similarly, if an electron loses the energy, it will drop from a higher level to a lower level. It may come from energy level 5 to energy level 4. Electrons gain energy through light. For example, after a moment, the electron returns to an energy level, and when it does that, it emits light of a certain color that depends on the materials. So, if, for example, light falls on some electron, it will gain some energy and it will jump from lower to higher orbit. But again, if, for example, the electron loses the energy, so how will it lose the energy? If it has taken some light in, it has gained energy. So when it loses the energy, the light must go out from the electron. Then the electron returns to its energy level. It emits light of a certain color, and that color depends on the material. The orbit or energy shell or level band furthest from the nucleus is called the valence shell, and the electrons in that orbit are known as valence electrons. So remember, valence electrons are those which are present in the outermost shell, the last one. So all the electrons which are present, they can be 1 and they can be up to 8. They are known as valence electrons. If an electron in the valence band receives energy through a particle of light, this particle of light or a packet of light is called a photon. It is released from the atom and remains in a free state. So, an atom without an electron from its last valence shell is called an ionized atom. Ionization breaks the neutral charge balance of the atom, making it positively charged. So I want to clarify this thing. If, for example, the last shell of the atom contains 8 electrons, it means that the valence shell is complete and there is no ionization present on the atom. But for example, an electron jumps out, making it ionized. As we have said earlier, that there are equal positive charges and equal negative charges, that is, equal number of protons equals the number of electrons. Then, if an electron goes out, it means now there is more positive charge left compared to negative charge. So it means that the electron is positively charged. Similarly, talking the other way around, if an electron comes in to the atom, so the number of electron will rise, and the number of electron rise means that negative charge has risen. Coming to the next one, the free electron can move without being tied to the nucleus, creating the motion of the electron. So when an electron jumps out, it is free of the nucleus and it can move freely. And this free motion is the electronic motion. This is called the electronic flow, and this phenomena is known as electronic current. Taking an example of copper, copper has an electron in its valence shell. This electron does not require much energy to become free. So copper is good conductive material at room temperature since it has many free electrons. A material with the same characteristics as copper is called a conductor. And most metals are good conductors. This example is, for example, silver, gold, and etc. So it means that all those materials which have the capacity or capability to remove the free electrons, they are known as conductors. And these electrons actually become part of this electronic flow or electronic current. On the other way around, if we have insulators, insulators means that they cannot release the electrons to move out of their shells. Rather, they demand the electrons. So they don't have the capacity to take participate in electronic current. So they become the insulators. So insulators means that they cannot permit the flow of current through them. And conductors are those which permit the flow of electric current through them. So now again, we come to another question of your session. That is question number 3. Now the question 3 for this session is, you should identify 3 elements which are good examples of electric conductor, and identify 3 examples of good insulators. By the way, good or bad insulators cannot be counted. They are all insulators. But on the other hand, uh, elements can be good conductors and bad conductors. So in the next lecture, we will be discussing this thing. What is the difference between good and bad conductors of electricity? And why are insulators so called, as I've told earlier as well? I want to know the 3 examples of good conductors and 3 examples of insulators. So now you should be able to search out for these questions and then tell me the answers to these questions anytime during your next week, and I will be waiting for you people. If you have any questions regarding today's lecture, you are free to ask me anytime via your internal email or on your collaborative forum. So you can answer me anytime. This recording will be available to you people as your resources, and you can be able to uh, hear and look around this presentation and this recording, and this will be helpful for you people in your final exams as well. So thank you very much for your patience and listening to me. We will be meeting in the next recording very soon. So please be present in lectures so that they can be interactive and you people can easily understand what we are teaching in class. So thank you very much for today. We will meet soon.